Hello everybody, this is our video solution to problem 5 from Quiz 10, Fall 2023, Math 307 Linear Algebra at Cal State Fullerton. So in this problem, we are given two linear maps from C2 to C2, right? So they're linear operators. And we know that with respect to the standard basis, so that, by the way, is an orthonormal basis, we know that the matrices are given as, well, what you see here, right? So the two operators are S and T, and the matrix of S is, let's see, 2 plus I, 4 plus 6I, 4 plus 6I, 2 minus I. While M of T is 3, 13 plus 7I, 13 minus 7I, and 4. And we want to determine whether S and T are self-adjoint. So the important result here is that we can tell whether one, and if you like, one operator is self-adjoint if and only if, with respect to an orthonormal basis, and again, we have the standard basis here, which we know is orthonormal. If with respect to an orthonormal basis, we know that the matrix for the adjoint of an operator, so the matrix, say, for S star, we know that this is equal to the complex conjugate of the matrix of S, and then we take the transpose. All right, this is with respect to an orthonormal basis. And therefore, if M of S star, well, we know that this is equal to M of S, if and only if S star is equal to S. Okay, that is self-adjoint. So M of S star equals M of S, if and only if M of S complex conjugate transpose is equal to M of S. So that's all I have to do, is check the conjugate transpose of the matrix, and if it's the same, then the operator is self-adjoint. So we can really quickly, when we start to do, say, M of S here, so if I write down M of S, and I do the complex conjugate, well, the very first thing that's going to happen is I take the complex conjugate of 2 plus I, and I get 2 minus I. And then I could do the transpose later on, but things on the diagonal don't change when I do the transpose. So it doesn't even matter what all the other stuff here is. This is definitely not equal to 2 plus I, and then, well, it doesn't matter what all the other stuff is. And therefore, S star does not equal S, and so S is not self-adjoint. Oh, okay. Well, then what about M of T? Right? Well, I guess we just do that up here. We can take the complex conjugate transpose of M of T. And let's see. The 3, when I take the conjugate, I get a 3. The 4 on the diagonal, that just becomes a 4. Now, 13 plus 7i, that'll swap down into the 2, 1 position. And when I take the conjugate, 13 plus 7i becomes 13 minus 7i. And 13 minus 7i, that's going to move across. So I get 13, but I take the complex conjugate. So 13 minus 7i becomes 13 plus 7i. And hey, wait, that's exactly the same thing as M of T. And therefore, T star is equal to T, and so T is self-adjoint. Hey, that's it. Very cool. So if you know you're working with respect to the standard basis, or in general any orthonormal basis, it's very, very easy to decide if an operator is self-adjoint if you know a matrix for that operator with respect to that basis. All right, everybody, we will see you next time.